Hello everyone, welcome back to my channel, the IITian Coder. This video is for the learning of concepts of MODInverse. This video has been created due to some requests by multiple people regarding the previous question in CodeFusion CodeChef on calculating NCR mod P. So how do we calculate MODInverse? Basically, what is MODInverse? So suppose there are very large numbers. So let's take a simple case of calculating NCR. So it's basically n factorial by, let me write it for you. It's NCR equals n factorial by r factorial. I should increase the size. N minus r factorial. So now, as this is a big number, I need to take a mod P. But for that I need to calculate this very large number. And for that I need to calculate this n factorial alone, which can be very large. So I can't calculate n factorial without taking a mod m. Now if I have took n factorial mod m and r factorial mod m and n minus r factorial mod m, I can't divide them because that would create fractions and would not give a perfect answer. That's why we use MODInverse in this case. MODInverse is basically, so this answer becomes n factorial, also known as multiplicative inverse, mod m. Instead of dividing, we multiply with A inverse mod m or R inverse mod m. Take the whole mod and then multiply it with n minus R inverse mod m and then take the whole mod. Okay, so let me show you. Okay, so how do we get this R inverse mod m? What is basically R inverse mod m? So basically the multiplicative inverse of a number, I will write it for you. The multiplicative inverse of a number is x if a into x is equal to mod m is equal to 1. This is the definition of multiplicative inverse. The multiplicative number of a number a is x if a into x is mod. By definition, this is the rule. So now I will show you how can we calculate this multiplicative inverse. The easiest way or the most naive way is to check all numbers from 1 to okay also, and there is one more condition: x should be greater than equal to 1 and x should be less than equal to n. Less than n. Okay, so now what do? We just check for all numbers from 1 to m minus 1 and whichever numbers mod m is equal to 1 after multiplying with a, we just print it. Also, one more condition for this to exist is basically A and M should be co-prime. So this is a naive approach. OM time, check all numbers. Check all. Now I will show to you one more approach, and then I will show you the final approach which is useful in competitive programming. So basically the second approach is using extended Euclidean algorithm. I will write in text. Let us extend this also. Extended Euclidean algorithm. So what do? We take ax plus my is equal to 1. This is the situation. Okay. Now we know that GCD of a comma m is equal to 1 because this is the condition for the modular inverse to exist. So we just take a mod m both sides, so it becomes ax mod m plus my mod m is equal to 1 mod m. So my mod m is basically 0, so it becomes ax mod m is equal to 1 mod m. So basically we just need to find the value of x using extended Euclidean algorithm, which is very easy. Now I will demonstrate to you the best approach which is used in most competitive programming questions for finding mod inverse. It is basically the use of modular inverse using binary exponentiation slash Fermat's theorem. What is Fermat's theorem? So Fermat's theorem states that a raised to m minus 1 mod m is equal to 1. Multiply both sides by a inverse. So in order to make things easy, we will assume that m is prime. Otherwise we need to do a lot of things, and we need to compute phi of m, which is basically the Euler-Stoichid function and all. But that doesn't happen in competitive programming. Usually m is 10 raised to 9 plus 7 or m is 9, 8 something, which are both prime numbers. So a raised to m minus 2 mod m is equal to a raised to minus 1 mod m. So hence we just need to calculate a raised to m minus 2. Now we prove this theorem that a raised to simply consider all the multiples of a till f minus 1a. Now if any of them two are same, that means but this is not possible. So because we have considered m minus 1 numbers, hence this means that this sequence is congruent to mod m That means dividing both sides by n minus 1 factorial. Hence proved. So please do take a look at the tutorial and this concept. It's an important concept. This means you can just find a raised to m minus 1 in log m time, and a raised to m minus 2 also in log n time. That means you can find the multiplicative inverse in log m time. So hope you understood this tutorial. Please do like, share and subscribe, and ask your doubts in the comment section. Thank you so much.